Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Thanks to Julie Gibson for sponsoring this episode about Cecilia Payne-Gaposchkin. It also includes a couple of extra articles, one about Astronomer and one about Harvard College Observatory. If you would like to sponsor an episode and support the podcast, head over to my website for more details. Cecilia Payne-Gaposchkin, born Cecilia Helena Payne, May 10, 1900 to December 7, 1979, was a British-American astronomer and astrophysicist. In her 1925 doctoral thesis, she proposed that stars were composed primarily of hydrogen and helium. Her groundbreaking conclusion was initially rejected by leading astrophysicists, including Henry Norris Russell, because it contradicted the science of the time, which held that no significant elemental differences distinguished the Sun and Earth. Independent observations eventually proved that she was correct. Overcoming barriers for female scientists, Payne did not receive a degree from Cambridge despite completing her studies. Her work on the cosmic makeup of the universe and the nature of variable stars was foundational to modern astrophysics. She was elected to the Royal Astronomical Society while still a student at Cambridge, and later became the first recipient of the American Astronomical Society's prestigious Annie J. Cannon Award. Her success also opened the door for countless female astronomers, including her Harvard colleague Helen Sawyer Hogg, and in 1956, she was appointed Harvard's first female professor and female department chair. Cecilia Helena Payne, born in Wendover in Buckinghamshire, England, was one of three children to Emma Leonora Helena and Edward John Payne, a London barrister, historian, and musician who had been an Oxford Fellow. Her mother came from a Prussian family and had two distinguished uncles, historian Georg Heinrich Pertz and the Swedenborgian writer James John Garth Wilkinson. When Cecilia was 4, her father died, leaving her mother to raise the family on her own. Payne began her formal education in Wendover at a private school run by Elizabeth Edwards. When Payne was 12, her family moved to London to support her brother Humphrey's education. He later became an archaeologist. Payne initially attended St. Mary's College, Paddington, where she was unable to study much mathematics or science. In 1918, she transferred to St. Paul's Girls' School, where her music teacher, Gustav Holst, encouraged her to pursue a career in music. However, Payne decided to focus on science. The following year, she won a scholarship covering her expenses at Newnham College, Cambridge University, where she studied physics and chemistry. Her interest in astronomy began after she attended a lecture by Arthur Eddington, detailing his 1919 expedition to the island of Principe in the Gulf of Guinea, off the west coast of Africa, to observe and photograph the stars near a solar eclipse, as a test of Albert Einstein's general theory of relativity. She said of the lecture, "The result was a complete transformation of my world picture. My world had been so shaken that I experienced something very like a nervous breakdown." Although she completed her studies, she did not receive an official degree because Cambridge did not grant degrees to women until 1948. Payne realized that her only career option in the UK was to become a teacher, so she looked for grants that would enable her to move to the United States. L.J. Leslie John Comrie, an astronomy PhD candidate at Cambridge University, introduced her to Harlow Shapley, a director of the Harvard College Observatory, had a lecture in London at the British Astronomical Association. In 1923, Payne moved to the United States to study at Harvard College, enabled by a fellowship established to encourage women to study at the Harvard Observatory. Adelaide Ames had been the first recipient of this fellowship in 1922, with Payne following as the second. Lawrence H. Aller later described Payne as one of the most capable go-getters in Shapley's observatory. Shapley persuaded Payne to write a doctoral dissertation, and so in 1925 she became the first person to earn a PhD in astronomy from Radcliffe College of Harvard University. Her thesis title was Stellar Atmospheres, a contribution to the observational study of high temperature in the reversing layer of stars. While analyzing glass plates at the Harvard College Observatory, Payne made a groundbreaking discovery by accurately relating the spectral classes of stars to their actual temperatures using Indian physicist Meghnad Saha's ionization theory. She demonstrated that the great variation in stellar absorption lines was due to differing amounts of ionization at different temperatures, not to varying amounts of elements. Payne found that silicon, carbon, and several common metals seen in the sun's spectrum were present in about the same relative amounts as on Earth, which aligned with the prevailing belief that stars had a similar elemental composition as on Earth. However, she also found that helium, and particularly hydrogen, were vastly more abundant in stars, with hydrogen being about 1,000,000 times more prevalent, leading her to conclude that hydrogen was the overwhelming constituent of stars, making it the most abundant element in the universe. However, when Payne's dissertation was reviewed, Henry Norris Russell, a preeminent astronomer of the day who adhered to the theories of American physicist Henry Rowland, urged her not to assert that the composition of the sun was predominantly hydrogen, because it contradicted the scientific consensus of the time that the elemental composition of the sun and the earth were similar. Russell, in a 1914 article, had argued that the agreement of the solar and terrestrial lists is such as to confirm very strongly Rowland's opinion that if the Earth's crust should be raised to the temperature of the sun's atmosphere, it would give a very similar absorption spectrum. The spectra of the sun and other stars were similar, so it appeared that the relative abundance of elements in the universe was like that in Earth's crust. Consequently, Russell described her results as spurious. Although she included all calculations and results, Payne agreed to write in her thesis that her results were almost certainly not real. 4 years later, however, Russell realized that Payne had been correct when he derived the same results by different means, effectively demonstrating that hydrogen and helium were the most abundant elements in the Milky Way. Sharing his results in 1929, Russell briefly acknowledged Payne's earlier work and discovery, including the mention that the most important previous determination of the abundance of the elements by astrophysical means is that by Miss Payne. Nevertheless, Russell was generally credited for the conclusions she had reached 4 years prior. Nearly 40 years after Payne's thesis was published, astronomer Otto Struve described her work as the most brilliant PhD thesis ever written in astronomy. Today's accepted ratios for hydrogen and helium in the Milky Way galaxy are roughly 74% hydrogen and roughly 24% helium, confirming the results of Payne-Gaposchkin's calculations from 1925. After earning her doctorate in 1925, Payne remained at Harvard for the entirety of her academic career. Initially, women were barred from becoming professors at Harvard, so she spent years doing less prestigious, low-paid research jobs. Her early work focused on stars of high luminosity to understand the structure of the Milky Way. Later, she surveyed all stars brighter than the 10th magnitude. She then studied variable stars, making over 1,250,000 observations with her assistants. This work later was extended to the Magellanic Clouds, adding a further 2 million observations of variable stars. These data were used to determine the paths of stellar evolution. She published her conclusions in her second book, The Stars of High Luminosity, 1930. On a tour through Europe in 1933, Payne met Russian-born astrophysicist Sergei Gaposchkin in Germany. She helped him obtain a visa to the United States, where they married in March 1934. Her observations and analysis of variable stars carried out with Sergei Gaposchkin laid the basis for all subsequent work on such objects. Her work resulted in several published books, including The Stars of High Luminosity, 1930, Variable Stars, 1938, and Variable Stars and Galactic Structure, 1954. Harlow Shapley, the director of the Harvard College Observatory, had made efforts to improve her position, and in 1938 she was given the title of Astronomer. On Payne's request, her title was later changed to Phillips Astronomer, an endowed position which would make her an officer of the university. In order to get approval for her title, Shapley assured the university that giving Payne-Gaposchkin this position would not make her equivalent to a professor, but privately pushed for the position to be later converted into an explicit professorship as a Phillips Professor of Astronomy. She was elected a Fellow of the American Academy of Arts and Sciences in 1943. Her courses were not recorded in the Harvard University catalog until 1945. When Donald Menzel became director of the Harvard College Observatory in 1954, he tried to improve her appointment, and in 1956 she became the first woman to be promoted to full professor from within the faculty at Harvard's Faculty of Arts and Sciences. She was appointed the Phillips Professor of Astronomy in 1958. Later, with her appointment to the chair of the Department of Astronomy, she also became the first woman to head a department at Harvard. Her students included Joseph Ashbrook, Frank Drake, Harlan Smith, and Paul W. Hodge, all of whom made important contributions to astronomy. She also supervised Helen Sawyer Hogg, Frank Kameny, and Owen Gingrich. Payne-Gaposchkin retired from active teaching in 1966 and was subsequently appointed Professor Emerita of Harvard. She continued her research as a member of staff at the Smithsonian Astrophysical Observatory, as well as editing the journals and books published by Harvard Observatory for 10 years. She edited and published the lectures of Walter Bade as Evolution of Stars and Galaxies, 1963. Payne-Gaposchkin's career marked a turning point at Harvard College Observatory. Under the direction of Harlow Shapley and Dr. E. J. Sheridan, whom Payne-Gaposchkin described as a mentor, the observatory had already offered more opportunities in astronomy to women than did other institutions. This was evident in the achievements accomplished earlier in the century by Williamina Fleming, Antonia Maury, Annie Jump Cannon, and Henrietta Swan Leavitt. However, with Payne's Ph.D., women entered the mainstream. The trail she blazed into the largely male-dominated scientific community was an inspiration for many. For example, she became a role model for astrophysicist Joan Feynman. Feynman's mother and grandmother had dissuaded her from pursuing science since they believed women were not physically capable of understanding scientific concepts. Feynman was inspired by Payne-Gaposchkin when she came across her work in an astronomy textbook. Seeing Payne-Gaposchkin's published research convinced Feynman that she could, in fact, follow her scientific passions. While accepting the Henry Norris Russell Prize from the American Astronomical Society, Payne spoke of her lifelong passion for research. The reward of the young scientist is the emotional thrill of being the first person in the history of the world to see something or understand something. Nothing can compare with that experience. The reward of the old scientist is the sense of having seen a vague sketch grow into a masterly landscape. In her autobiography, Payne said that while in school she created an experiment on the efficacy of prayer by dividing her exams into two groups, praying for success only on one, the other one being a control group. She achieved the higher marks in the latter group. Later on, she became an agnostic. In 1931, Payne became a United States citizen, so held joint citizenship of both the UK and the US. On a tour through Europe in 1933, she met Russian-born astrophysicist Sergei Gaposchkin in Germany. She helped him get a visa to the United States, and they married in March 1934, settling in the historic town of Lexington, Massachusetts, a short commute from Harvard. Payne added her husband's name to her own, and the Payne-Gaposchkins had 3 children, Edward, Catherine, and Peter. Payne's daughter remembers her as an inspired seamstress, an inventive knitter, and a voracious reader. Payne and her family were members of the First Unitarian Church in Lexington, where Cecilia taught Sunday school. She was also active with the Quakers. She died at her home in Cambridge, Massachusetts on December 7, 1979, aged 79. Shortly before her death, Payne had her autobiography privately printed as The Dyer's Hand. It was later reprinted as Cecilia Payne-Gaposchkin, an autobiography and other recollections. Payne's younger brother Humphrey Payne, 1902 to 1936, who married author and film critic Dilys Powell, became director of the British School of Archaeology at Athens, where he died in 1936, age 34. Payne's granddaughter Cecilia Gaposchkin is a professor of late medieval cultural history and French history at Dartmouth College, New Hampshire. Honors and awards. Elected member of Royal Astronomical Society while still a student at Cambridge, 1923. Became one of 250 scientists added to the 4th edition of American Men of Science, 1927. Annie J. Cannon Award in Astronomy, 1934, first recipient. Member of the American Philosophical Society, 1936. Member of the American Academy of Arts and Sciences, 1943. Award of Merit from Radcliffe College, 1952. Rittenhouse Medal from the Rittenhouse Astronomical Society at the Franklin Institute, 1961. Professor Emerita of Harvard University, 1967. Asteroid 2039, Payne-Gaposchkin, discovered in 1974, is named after her. Henry Norris Russell Lectureship of the American Astronomical Society, 1976. Institute of Physics Cecilia Payne-Gaposchkin Medal and Prize, named in her honor, 2008. The American Physical Society's Doctoral Dissertation Award in Astrophysics, renamed the Cecilia Payne-Gaposchkin Doctoral Dissertation Award in Astrophysics, 2018. One of the ASAS-SN telescopes deployed in South Africa was named after her. Honorary degrees from Rutgers University, Wilson College, Smith College, Western College, Colby College, and the Women's Medical College of Pennsylvania. The Payne-Gaposchkin Patera volcano on Venus is named after her. An astronomer is a scientist in the field of astronomy who focuses on a specific question or field outside the scope of Earth. Astronomers observe astronomical objects such as stars, planets, moons, comets, and galaxies in either observational by analyzing the data or theoretical astronomy. Examples of topics or fields astronomers study include planetary science, solar astronomy, the origin or evolution of stars, or the formation of galaxies. A related but distinct subject is physical cosmology, which studies the universe as a whole. Astronomers typically fall under either of two main types, observational and theoretical. Observational astronomers make direct observation of celestial objects and analyze the data. In contrast, theoretical astronomers create and investigate models of things that cannot be observed. Because it takes millions to billions of years for a system of stars or a galaxy to complete a life cycle, astronomers must observe snapshots of different systems at unique points in their evolution to determine how they form, evolve, and die. They use this data to create models or simulations to theorize how different celestial objects work. Further subcategories under these two main branches of astronomy include planetary astronomy, astrobiology, stellar astronomy, astrometry, galactic astronomy, extragalactic astronomy, or physical cosmology. Astronomers can also specialize in certain specialties of observational astronomy, such as infrared astronomy, neutrino astronomy, X-ray astronomy, and gravitational wave astronomy. Historically, astronomy was more concerned with the classification and description of phenomena in the sky, while astrophysics attempted to explain these phenomena and the differences between them using physical laws. Today, that distinction has mostly disappeared, and the terms astronomer and astrophysicist are interchangeable. Professional astronomers are highly educated individuals who typically have a PhD in physics or astronomy and are employed by research institutions or universities. They spend the majority of their time working on research, although they quite often have other duties such as teaching, building instruments, or aiding in the operation of an observatory. The American Astronomical Society, which is the major organization of professional astronomers in North America, has approximately 8,200 members as of 2024. This number includes scientists from other fields such as physics, geology, and engineering, whose research interests are closely related to astronomy. The International Astronomical Union comprises about 12,700 members from 92 countries who are involved in astronomical research at the PhD level and beyond, as of 2024. Contrary to the classical image of an old astronomer peering through a telescope through the dark hours of the night, it is far more common to use a charge-coupled device, CCD camera, to record a long, deep exposure, allowing a more sensitive image to be created because the light is added over time. Before CCDs, photographic plates were a common method of observation. Modern astronomers spend relatively little time at telescopes, usually just a few weeks per year. Analysis of observed phenomena, along with making predictions as to the causes of what they observe, takes the majority of observational astronomers' time. Astronomers who serve as faculty spend much of their time teaching undergraduate and graduate classes. Most universities also have outreach programs, including public telescope time and sometimes planetariums, as a public service to encourage interest in the field. Those who become astronomers usually have a broad background in physics, mathematics, sciences, and computing in high school. Taking courses that teach how to research, write, and present papers are part of the higher education of an astronomer. While most astronomers attain both a master's degree and eventually a PhD degree in astronomy, physics, or astrophysics. PhD training typically involves 5 to 6 years of study, including completion of upper-level courses in the core sciences, a competency examination, experience with teaching undergraduates, and participating in outreach programs, work on research projects under the student's supervising professor, completing a PhD thesis, and passing a final oral exam. Throughout the PhD training, a successful student is financially supported with a stipend. While there is a relatively low number of professional astronomers, the field is popular among amateurs. Most cities have amateur astronomy clubs that meet on a regular basis and often host star parties. The Astronomical Society of the Pacific is the largest general astronomical society in the world, comprising both professional and amateur astronomers, as well as educators from 70 different nations. As with any hobby, most people who practice amateur astronomy may devote a few hours a month to stargazing and reading the latest developments in research. However, amateurs span the range from so-called armchair astronomers to the highly ambitious people who own science-grade telescopes and instruments with which they are able to make their own discoveries, create astrophotographs, and assist professional astronomers in research. The Harvard College Observatory, HCO, is an institution managing a complex of buildings and multiple instruments used for astronomical research by the Harvard University Department of Astronomy. It is located in Cambridge, Massachusetts, in the United States, and was founded in 1839. With the Smithsonian Astrophysical Observatory, it forms part of the Center of Astrophysics, Harvard and Smithsonian. HCO houses a collection of approximately 500,000 astronomical plates, taken between the mid-1880s and 1989, with a gap from 1953 to 1968. This 100-year coverage is a unique resource for studying temporal variations in the universe. The Digital Access to a Sky Sentry at Harvard project is digitally scanning and archiving these photographic plates. In 1839, the Harvard Corporation voted to appoint William Cranch Bond, a prominent Boston clockmaker, as astronomical observer to the university at no salary. This marked the founding of the Harvard College Observatory. HCO's first telescope, the 15-inch Great Refractor, was installed in 1847. That telescope was the largest in the United States from installation until 1867. Between 1847 and 1852, Bond and pioneer photographer John Adams Whipple used the Great Refractor Telescope to produce images of the moon that are remarkable in their clarity of detail and aesthetic power. This was the largest telescope in North America at the time, and their images of the moon took the prize for technical excellence in photography at the 1851 Great Exhibition at the Crystal Palace in London. On the night of July 16th through the 17th, 1850, Whipple and Bond made the first daguerreotype of a star, Vega. Harvard College Observatory is historically important to astronomy, as many women, including Annie Jump Cannon, Henrietta Swan Leavitt, Cecilia Payne-Gaposchkin, Williamina Fleming, and Florence Cushman, performed pivotal stellar classification research. Cannon, Leavitt, and Cushman were hired initially as computers to perform calculations and examine stellar photographs, but later made insightful connections in their research. From 1898 to 1926, a series of bulletins were issued containing many of the major discoveries of the period. These were then replaced by announcement cards, which continued to be issued until 1952. In 1908, the observatory published the Harvard Revised Photometry Catalog, which gave rise to the H.R. Star Catalog, now maintained by the Yale University Observatory as the Bright Star Catalog.